Hi, good evening, class. So, today our topic is 3D vectors, in which basically we are going to cover lines and planes. A general equation of the line is x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. Here, x1, y1, z1 is the point through which line passes, and A, B, C are direction ratios of line. These direction ratios means if we are having any vector parallel to the line, let's say we are having this line and there is a vector ai cap plus bj cap plus ck cap, then the direction ratios of the line will be a, b and c. For plane, the general equation of plane is ax plus, let's write it capital Ax plus by plus cz equals to d. Here this ABC represents direction ratios of perpendicular to the plane. Okay. So these are the basic things we must know. Let's move to the first question. Our first question is, we are given the equation of a plane x minus 2y plus 7z plus 21 equals to 0. And it is asked, first question is, it contains this line, contains this point, it is perpendicular to this line and it is parallel to the given plane. Okay, for this one, if we are having this plane, let's say, and it contains a line, then for a equation of plane ax plus by plus cz equals to d, a, b, c are the direction ratios of perpendicular to the plane. And for the line x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c, a, b, c are direction ratios of the line, that is along the line. These two are perpendicular. If we say line is contained in plane, then it must follow two conditions. First, x1, y1, z1 must be on plane, so that should satisfy the equation of plane. And secondly, AA plus BB plus CC should be equals to 0. So for the first one, it will be minus 3 into 1 plus 2 into minus 2 plus 1 into 7. So this value is coming out to be 0. So our condition this is satisfied. Now for the point minus 1, 3, minus 2, let's check whether it is on the plane or not. See, it is an MCQ type question, so it will have multiple on answers correct. This is the first question. So let's satisfy this point. Minus 1 minus 2 into 3 plus 7 into minus 2 plus 21. So it is minus 1 minus 6 minus 14 plus 21. So it is coming out to be 0. That means this line is satisfying our both the conditions. So answer A is correct. Let's move to the next question. It contains this point. Let's try to satisfy it. So 0 minus 2 into 7 minus 7 plus 21. Yeah, it is coming out to be 0. So it contains this point because this point is satisfying the equation of the plane. Third, it is perpendicular to the line. See, the direction ratios of perpendicular to the plane are 1, minus 2 and 7. And the direction ratios of this line are 1, minus 2 and 7. If the direction ratios are in the form a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, then vectors are parallel. So here the perpendicular to the line and this line both have the direction ratios in the same proportion. So yeah, our option number C is also correct. Next, it is parallel to this plane. We can see here the direction ratios for planes also. These are the perpendicular to the plane and the direction ratios of this plane are 1, minus 2 and 7. So these two have the same direction ratios. That means if this plane has this perpendicular and the other plane is having the same direction ratios for the perpendicular, that means plane 1 and plane 2 are parallel. Or you can use the basic concept, if a1x plus b1y plus c1z equals to d1 and a2x plus b2y plus c2z equals to d2 are first case parallel planes, then a1 upon a2 equals to b1 by b2 equals to c1 by c2, and if they are perpendicular planes, then they are a1 a2 plus b1 b2 plus c1 c2 equals to 0. Now moving to our next question, so our option number D is also correct. So for this question we are having all the options correct. See, for a plane and line, the concept is, if we are having a plane, let's say this is the plane, and the equation of plane is x plus by plus cz equals to d, then a b c are direction ratios of this vector of perpendicular to plane. And for a line, x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. Here, a, b, c are direction ratios along line. So in this part, 1, minus 2 and 7 are direction ratios of perpendicular to the line. And for the C1, we can see the line has the direction ratios 1, minus 2 and 7. So it is clear that the perpendicular to the plane and the line both have same direction ratios. Perpendicular to the plane is having the direction ratios 1, minus 2 and 7, and the line equation, the line is also having the direction ratios 1, minus 2, 7. So perpendicular to the plane and line, they are having the same direction ratios, hence we can say that plane is perpendicular to the line. Now moving to the next question. Our next question is, the direction ratios of the line are. See, in this case, we are given the equations of two planes. We know that the equation of line, the general equation of line is in the form of x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. But we also know that if we are having two planes like this and let's say this, these are the two planes. So when these two will intersect, then this line will pass through them. So a line always passes through the intersection of two planes. And now the direction ratios of perpendicular to this plane are 1, minus 1, 1. For this plane, 1, minus 3 and 0. Let's say we are having this line and this line is in the plane, it is along the plane, and the direction ratios of line be ABC. 1, minus 1 and 1 is direction ratios of perpendicular to plane 1. 1, minus 3 and 0 are direction ratios of, let's say, this plane, plane 2. So this line will be perpendicular to both these direction ratios. So for the perpendicular condition of the direction ratios, we are having a into 1 plus b into minus 1 plus c into 1 equals to 0. A into 1 minus 3b into 1 and c into 0 equals to 0. So from these two conditions, we can say a by 3 equals to b. Put this value of b here. A minus a by 3 plus c equals to 0. So c will come out to be minus 2a by 3. So we can say uh, that a equals to 3b and a equals to minus 3c by 2. So a equals to 3b equals to minus 3c by 2 divided by minus 3. So the direction ratios which we will get will be minus 3 minus 1 2 or 3 1 2 minus 2. So our option A is correct, and this is also correct because direction ratios are in the same proportion. So you can multiply or divide it by any value, you will get the same direction ratios. Now, let's move to the next question. Our next question is, we are given a line which makes angles alpha 1, alpha 2, alpha 3, alpha 4, alpha 5 with the diagonals of the cube. Then, so if we are having this cube and let's say the point A is at origin whose coordinates are 0, comma 0, comma 0, and the cube has side A, then point B which is along x-axis, let's say this is our x-axis, this is our y-axis, and this is our z-axis. So point B will have the coordinates a comma 0 comma 0. Point C, it is along x and y, so it is having the coordinates a0. Point D is having coordinates a0 a0, and similarly we can find the coordinates of the other points. Now we are concerned here about the body diagonals. So body diagonals are AF. So AF, if we are having the 2 points x1 y1 z1 and the other point is x2 y2 z2, then direction ratios of line joining the point is given by x2 minus x1 y2 minus y1 and z2 minus z1. Similarly, we can say the vector which is joining these 2 points is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So using this concept of of position vectors, we get the vector AF. It is AI cap plus AJ cap plus AK cap. Similarly, the other body diagonal we can see here, it is BE. B is this side and A is on the front side. So that will be 0 minus A minus 0, and A minus 0. So similarly, we have got the body diagonals. Now, let's say we are having some line which is making the angle alpha 1, alpha 2, alpha 3, alpha 4 with these body diagonals, and its direction cosines are L, comma M, comma N. So cos alpha will come out to be, we are having this basic concept of angle between the two vectors, cos theta equals to A dot B upon mod A into mod B. So from this, cos alpha will be AL plus AM plus AN. Similarly, cos alpha 2 will be minus A into L plus A into M plus A into N upon mod of under the root L square plus M square plus N square is 1, and under the root A square plus A square plus A square will be root 3A. So from this we can find the value of cos alpha 1, cos alpha 2, cos alpha 3 and cos alpha 4. Moving to our question, and what all options we have to look for here. First is we were having the values of cos alpha 1. The value of cos alpha 1 was AL plus AM plus AN upon root 3a. So this a will be cancelled out. We can say it is L plus m plus n by root 3. Similarly, cos alpha 2 will be minus L plus m plus n by root 3. Cos alpha 3 was L plus m minus n by root 3. And cos alpha 4, its value is L minus m plus n by root 3. Now, squaring all these values and adding, so cos square alpha 1 will come out to be L square plus m square plus n square plus 2lm plus 2mn plus 2nl, and it will be 1 by 3. And you will, when you will do summation here, so for this part, it is positive L into M and this will be negative L into M. This will be positive and this will be negative. So two values will be positive, two will be negative. So those values will cancel out. So we won't get the L into M part. We will be getting this part 4 times. Now here M into N is positive, here M into N is positive, here M into N will be negative, here also negative. So two positive, two negative, this will also get cancelled out. Similarly, for N into L, this is positive, this is negative, and this is positive. So similarly, 2 times N into L will be positive and 2 times it will be negative. So this will be also get cancelled out. And L square plus M square plus N square, since it is a direction cosine, so sum will be equals to 1. So we will get answer 4 by 3. Sir, option 1 is correct. C is correct, sorry. Now, moving to this question. Cos 2. So cos 2 theta is 2 cos square theta minus 1. So on summation, we will be getting cos 2 alpha I will be 2 times of summation of cos square alpha I minus summation of 1. So this will be added 3 times. So 2 into 4 by 3 minus 3. So that will be minus 1 by 3. Okay. Similarly, for cos square theta is 1 minus sine square theta. So 1 minus sine square alpha 1 plus 1 minus sine square alpha 2 plus 1 minus sine square alpha 3 plus 1 minus sine square alpha 4. Oh yeah, sorry. That is minus 4. So that will be, answer will be this. So minus 1. So minus 4 by 3 it will be. Okay, sorry. So here 1 minus sine square alpha 1. So our option number A is also correct. And sine square alpha 4, that is 4 by 3. So again it will be like 4 minus 4 by 3 equals to summation of sine square alpha I. So this also is minus 4 by 3. Oh, sorry. 12 minus 4 minus, that will be 8 by 3. This option is wrong. This is 8 by 3. So the correct answers will be, okay, here some misprinting is there. So our correct options are coming out to be A and C. Moving to the next question. We are given that the lines intersect at a point alpha comma beta comma gamma, and we are asked to find the value of lambda. So what we have to do here is if we are having the two lines, they are intersecting. Let's say they intersect at this point A. 1, 1 and lambda are the direction ratios along the line. So we can say that we are having a vector along this line 1 whose value is I cap plus lambda times of j cap. Lambda 2 and 1 are the direction ratios along the line 2. So we can say that the vector along this line is lambda I cap plus 2j cap plus k cap. Now this line passes through the point 2, 3, 4 and this line passes through the point 1, 4, 5. If we will join these 2 points, let's say this point is P and Q. So the vector PQ will be 1 minus 2, that is minus I cap minus j cap minus k cap. 1 minus 2 I cap plus 4 minus 3 j cap plus 5 minus 4 k cap. So that vector will be minus I cap plus j cap plus k cap. So here we can see that these three vectors are coplanar. These three vectors are lying on a same plane. So for three vectors to be coplanar, the determinant value of their coefficients is 0. So we will be getting 1, 1, lambda, lambda 2, 1 and 1, 4, 5. Oh sorry, 1, oh sorry, minus 1, 1 and 1 equal to 0. So on solving this determinant, 2 into 1 minus 1 into lambda plus 1 plus lambda into lambda plus 2 equals to 0, we will be getting 1 minus lambda minus 1 plus lambda into lambda plus 2. So that will be 1 minus this and lambda square plus 2 lambda equals to 0. So we will be getting lambda square plus lambda equals to 0. So taking lambda common, lambda plus 1 equals to 0. This implies that lambda equals to 0 or minus 1. So the two values of lambda are 0 and minus 1. So our options are A and B. So we can get this as a concept that if we are having the two lines x minus x1 upon a1 equals to y minus y1 upon b1 equals to z minus z1 upon c1 equals to 0 and the other is x minus x2 upon a2 equals to y minus y2 upon b2 equals to z minus z2 upon c2 equals to 0, then they intersect when modulus of a1 b1 c1 a2 modulus sorry determinant value of a1 b1 c1 a2 b2 c2 and x2 minus x1 y2 minus y1 z2 minus z1 is equals to 0. Moving to the next question, we are given if a line makes an angle theta with x and y axis, then cot theta can be equals to. So we know that if a line is making an angle theta with x-axis, then L will be equals to cos theta, M will be equals to cos theta, and N, we are not knowing what angle it is making with z-axis. So let's say it's make an angle gamma with z-axis. So L square plus M square plus N square equals to 1 from the property of direction cosines. We will be getting 2 cos square theta plus cos square gamma equals to 1. This implies that cos square gamma is 1 minus 2 cos square theta. Since the value of cos square gamma will lie anywhere between 0 to 1, so we can say that 1 minus 2 cos square theta will lie anywhere between 0 to 1. So using this, obviously this will be done because 1 minus 2 cos square theta will be always less than equals to 1. For the first condition, 1 minus 2 cos square theta greater than equals to 0. So 1 will be greater than equals to 2 cos square theta. So 1 by 2 less than equals to cos square theta. So we can say that the value of cos theta will be less than equals to 1 by root 2. If that value is 1 less than equals to 1 by root 2, this means that the angle will lie from pi by 4 to pi by 2. Because the graph of cos theta is like this, at pi by 4 its value is 1 by root 2, and after pi by 4 to pi by 2 its value is from 1 by root 2 to 0, or we can say that the value is less than 1 by root 2. So we are asked the value of cot theta that can happen. So cot theta will have value from pi by 4 to pi by 2. Cot pi by 4 is 1. So this value is possible. Cot pi by 2 is 0. This is possible. But value greater than 1 and smaller than minus 1 is not possible. So our options A and C are correct. Now, moving to the next question. Our question is, let PM be the perpendicular from the point P to XY plane, and OP makes an angle theta with the positive direction of Z axis, and OM makes an angle phi with the positive direction of X axis, where O is origin. We are given theta and phi both are the acute angles. Then we have to find the various conditions. Now see, if we are having y-axis, this is z-axis, and let's say this is x-axis. Now, this is our origin. We are having OP, which is making an angle theta with the positive direction of z-axis. So OP is making this angle theta with the positive direction of z-axis. So its component along z-axis will be OP. Let's say the length of OP be r, so it will be r cos theta. And its component along yz axis, xy axis, it will be, we are given PM is the perpendicular this point 1 comma 2 comma 3. We have drawn a perpendicular on xy plane. See, this is our xy plane, and we have drawn a perpendicular on it. So if you will imagine it in 3D, then PM is the perpendicular. So from a point P, we have drawn a foot of perpendicular that is dropping at point M in XY plane. And we are given that OM makes an angle phi with the positive direction of Y axis. OM is making this angle phi. See, this was our component r cos theta. So this will be the component. This component was along z-axis, and this component OM is perpendicular to the z-axis. That is, it is lying in an xy plane. So this component will be r sine theta. And for r sine theta, the component along x-axis will be r sine theta cos phi. बेसिक रूल, जिसके साथ एंगल बनता है उसके साथ वाला कंपोनेंट cos थीटा वाला, उससे परपेंडिकुलर वाला कंपोनेंट sin थीटा वाला. अब एंगल अगर एक्स एक्सिस के साथ बन रहा है तो एंगल फाई है, तो इसके लिए हमारा कंपोनेंट हो गया आर साइन थीटा का कंपोनेंट अलोंग एक्स एक्सिस आर साइन थीटा कॉस फाई, और वाई एक्सिस के अलोंग अगर हम उसका कंपोनेंट देखेंगे तो आर साइन थीटा का कंपोनेंट अलोंग वाई एक्सिस हो जाएगा आर साइन थीटा साइन फाई. Got it? Let's go through it one more time. See, we are having a point P. हमारे पास एक पॉइंट P है, हमारे पास पॉइंट O है, O से P हमने बनाया, और OP जो है इट इज मेकिंग एंगल थीटा विद जेड एक्सिस, वो जेड एक्सिस के साथ एंगल थीटा बनाता है, तो हमने उसका कंपोनेंट बनाया आर कॉस थीटा जो जेड एक्सिस पे आएगा, और एक कंपोनेंट बनेगा जो जेड एक्सिस से परपेंडिकुलर होगा. अब जेड एक्सिस से परपेंडिकुलर क्या, व्हाट इज परपेंडिकुलर टू जेड एक्सिस, तो फ्रॉम plane concept we can see that the perpendicular to the z axis is xy plane, so the component along xy plane is r sin theta because it is perpendicular to z axis. See, this is in 3D. Okay, now this r sin theta is making angle phi with x axis. r sin theta angle phi बनाता है x axis के साथ, तो उसका कंपोनेंट क्या हो जाएगा x axis के साथ, r sin theta cos phi. और r sin थीटा अगर x एक्सिस के साथ एंगल फाई बना रहा था, तो हमारे पास y एक्सिस जो उससे परपेंडिकुलर है उसका कंपोनेंट हो जाएगा r sin थीटा sin phi. So we can see that these coordinates are given on this perspective only. The coordinates along x-axis is 1, that is its component along x-axis is equals to 1. So we can see that r sin theta cos phi equals to 1. Its coordinate along y-axis is 2. So the component along y-axis is giving the coordinate along y-axis. So component along y-axis is r sin theta sin phi. So its value is 2. Its component along z-axis is giving us the coordinate along z-axis, that is 3. So r cos theta is equals to 3. Now we are having a sine theta sine phi, so we can say that if we will get the value of r, we can check whether sine theta sine phi is equals to this or not. So to find the value of r, we can easily find it. It is the distance between the origin and point P. So from distance formula, 1 square plus 2 minus 0 ka whole square, that is 4, plus 3 minus 0 ka whole square, that is 9. So r will be equals to root 14. So we can see that sine theta sine phi, yeah, it is equals to 2 by root 14. So our option B is correct. Now we need to find tan phi. So we can divide these two equations. Let's name it 1, 2, and 3. So when you will divide equation number 2 by equation number 1, so 2 upon 1, r sin theta will be cancelled out. Sin phi upon cos phi, it will be tan phi. So tan phi equals to 2. So our option number C is correct. Now let's check out for value of tan theta. So from this sin phi equals to 2, tan phi equals to 2, sorry, we can say sin phi will be equals to 2 upon root 5. This is perpendicular and base is 1, so hypotenuse will be root 5. So we can say sin phi, the value of sin phi will be equals to 2 upon root 5. So from equation number 2, we will get r sin theta into 2 upon root 5 equals to 2. And equation 3 is r cos theta equals to 3. On dividing these two, we will get tan theta upon root 5 equals to 1 by 3. So tan theta will be equals to root 5 by 3. So our option number A is also correct. Now we are having the value of sin phi. We can find the value of cos phi. Cos phi, it will be 1 by root 5. We are having the value of tan theta, or we can easily say we are having the value of cos theta from here. Cos theta is 3 by root 14. So cos theta equals to 3 by root 14. So from 3 by root 14 into 1 by root 5. So it is not equals to 1 by root 14. So our option number D is not correct. So correct answers are A, B, and C. Moving to the next question. Now we are given, let Pn be the perpendicular from the point to the xy plane if OP makes an angle alpha with the positive direction of z-axis and ON makes an angle beta with the positive direction of x-axis, where O is the origin. Then, right now we have seen that. So our x coordinate will be, anyone? Our x coordinate will be Akshat, Devashish, Manvi, Parth, Vamsi. No, no, no. That is our z coordinate. So our z coordinate will be r cos alpha. We are given the value angle is alpha with the positive direction of z axis. Secondly, for x axis, it will be r sine alpha, and it is making angle beta with the positive direction of x axis. So r sine alpha cos beta. And z y coordinate will be r sine alpha sine beta. Now we are given the value of r cos alpha, it's 3, x coordinate is 1, and this is 2. And the value of r under the root 14, similarly from the distance formula. So cos alpha will come out to be 3 by root 14. We can find the value of tan alpha from here. So tan alpha will come out to be 14 minus 9, that is 5, so root 5 by 3. See, I am using the Pythagoras theorem here. It is base and this is hypotenuse, so we can find the perpendicular. Perpendicular is equal to under the root hypotenuse square minus base square. So tan theta is perpendicular upon base. So our option number C is correct. Now, from this, let's check for option number A, root 14 sine alpha sine beta equals to 2. So sine alpha sine beta will be 2 by root 14. So option number A is correct. We are having the value of cos alpha from here. Cos alpha is 3 by root 14. Let's find the value of sine alpha. No, we are having cos alpha here. We have to find cos beta. So any easy trick you can do here? See, from cos alpha, you can find the value of sine alpha. Sine alpha will be root 5 by root 14. So from equation number this of x-axis, we are having r root 14. Sine alpha is root 5 by root 14 into cos beta, it is equals to 1. So cos beta, we are having 1 by root 5. So cos alpha into cos beta, 3 by root 14 into 1 by root 5, it is not equals to 1 by root 14. So B is not the correct option. Clear? Moving to the next question. Here we are given the equation of the lines written in the symmetrical form. See, what you can do here is, first of all, let us check what will be the direction cosines. So for that, you don't need to solve this thing. You can just see 1, 1, 1 is the direction cosines of this perpendicular to this plane. 4, 1, minus 2 are direction cosines of perpendicular to this plane. So let's check it. 1 into 1, minus 2 into 1, 1 into 1, it is 0. So these direction ratios are promising. They are showing 0. So 4 into 1 minus 2 into 1, that is 4 minus 2, 2 into minus 1. So these are correct direction ratios. We will go to the point also. So 1 minus 2 and 1, these two are our promising direction ratios. These say these three options are promising. Let's check for this one. 2 into 1 minus 1 plus 2. This is not coming 0, so our option D is terminated from here. Now, let's find the point. So for this one, the point of this line is, okay, point you need to find, because it is not mandatory that the line should satisfy that point. So from this, our direction ratios are clear. Let's go for the point. X plus y plus z minus 1 equals to 0, and 4x plus y minus 2z plus 2 equals to 0. Let's say our z coordinate is something k. So we will have x plus y equals to 1 minus k, and from here we will have 4x plus y equals to 2 k minus 2. Now subtracting these two equations, we will be having 3x equals to 2k minus 2 minus 1 plus k. So x coordinate will be 3k minus 3 upon 3. So that will be k minus 1. So putting x equals to k minus 1 plus y equals to 1 minus k. So our y is 2 minus 2k. So the coordinates which should be satisfied are k minus 1, 2 minus 2k, and k. Put the value k equals to 0. You will get minus 1, 2, 0. Any line passing through these coordinates? Yeah, first one. So answer A is correct. Putting k equals to 1, we will get 0, 0, 1. Any line passing through these coordinates? Yeah, option B is correct. Now let's check for 1 by 2. So for 1 by 2, we have to put this is k equals to 1, k equals to 1 by 2. So 1 by 2 minus 1, that will be minus 1 by 2. This coordinate will be 2 minus 2 into 1 by 2, that will be 1, and this is 1 by 2. So any line passing through minus 1 by 2, 1, 1 by 2, C. Or what you can do here is, you can see the coordinates of this line minus 1, 2, and 0. Try to satisfy it. So minus 1 plus 2 plus 0 minus 1, its whole quantity is coming out to be 0. So this line is cool. You don't have to solve it. You can go by options also here. 0, 0, and 1. So 0, 0, 1. 1 minus 1, it is 0. So this is also cool. Now for the option C, these points are minus 1 by 2, 1, 1 by 2. Check it. Minus 1 by 2 plus 1 by 2 will get cancelled. 1 and minus 1 will get cancelled out. So it is also coming out to be 0. So option C is correct. Clear? Moving to the next question. We are given, let A, B, and C be the 3 points. Then the equation of the plane parallel to the plane ABC, which is at a distance of 2 is. So if we are having a plane through the 2 points, sorry, 3 points. This is A, B, C. So we can find a vector AB and we can find the vector BC. So vector AB will be 2 minus 1, 1 I cap, plus 3 minus 1, 2 J cap, plus 5 minus 1, that is 4k cap. And vector AC we are having minus 1 minus of minus 1, that is minus 2 I cap, 0 minus 1 minus j cap, 2 minus 1 plus k cap. So we are having the two vectors along the plane. And for the equation of the plane, the basic general condition is you need to find a vector perpendicular to the plane. So to find a vector perpendicular to the plane, we know that the cross product of two coplanar vectors gives a vector which is perpendicular to the plane. So the cross product will be I cap, j cap, k cap, 1, 2, 4, minus 2, minus 1, 1. So on solving this, you will get minus 2 I cap. No. You will get 2 plus this. So this will be 6 I cap. For j, it will be 1 plus 8. So that will be 9 plus k cap. This will be minus 1 minus of minus plus 4. So minus 1 plus 4, that will be 3. So taking 3 common, it will be 2I cap minus 3j cap plus k cap. So the direction ratios of perpendicular to the plane are 2, minus 3, 1, or any multiple of it. So which all planes are satisfying are this condition? This. See, if we are going by the by options, now if you are going by options, okay, if you don't want to solve it full, then just see here we are having all the four options which satisfy this direction ratios. So this step is not needed then. We already know one of the four or more than one out of the four will be the correct option. So that means the direction ratios of perpendicular to the plane are 2, minus 3, and 1. Now our plane also passes through these points. So the equation of the plane passing through this point will be a into x minus x1 plus b into y minus y1 plus c into z minus z1. So a we are having 2 x minus 1 plus b we are having minus 3 y minus 1 plus c we are having 1 z minus 1 equals to. On simplifying, you will get 2x minus 3y plus z minus 2 plus 3 minus 1. So minus 2 plus 3 will be 1 and minus 1 it will be 0. So the equation of this plane is 0. 3x minus 2x minus 3y plus z equals to 0. Now, what we have to find? We are having the equation of this plane which is passing through ABC, but we have to find the equation of the plane which is parallel to this plane and it is at a distance of 2. So for the two planes to be parallel, the direction ratio should be same. So let's say the equation of that plane is 2x minus 3y plus z equals to k. So distance between the parallel planes is, if we are having the parallel planes ax plus by plus cz equals to d1 and ax plus by plus cz equals to d2, then distance between them, yeah, perpendicular distance between them is given by mod of d2 minus d1 upon under the root a square plus b square plus c square. Now that distance we are given, we are having this plane 2x minus 3y plus z equals to 0. So that will be k minus 0 upon under the root 4 plus 9 plus 1 equals to 2. So k will be plus minus 2 root 14. So let's check the options. So 2 root 14 is only in option number A. So our option which is correct is option A. Moving to the next question. The coordinates of the point on the line x minus 1 by 2 equals to y plus 1 upon minus 3 equals to z at a distance 4 root 14 from the point 1 minus 1 0 r. So we need to find the coordinates of a point on this line. So let's say this value is equals to some constant lambda. So x minus 1 by 2 equals to y plus 1 upon minus 3 equals to z equals to lambda. So x coordinate will be 2 lambda plus 1, y coordinate will be minus 3 lambda minus 1, and z coordinate will be lambda. Now it is given the distance from this point and this point is equals to 4 root 14. So applying the distance formula under the root x2 minus x1, so 2 lambda plus 1 minus 1 whole square plus minus 3 lambda minus 1 minus of minus 1 whole square plus lambda minus 0, that is lambda square, is equals to 4 root 14. On simplifying you will get 4 lambda square plus this 1 and 1 will get cancelled out. 9 lambda square plus lambda square equals to 4 root 14. So we will be having root 14 into lambda equals to 4 root 14. Or we can say that it is lambda square, so 14 lambda square equals to 4 square into root 14 ka square, that is 14. So lambda square is equals to 4, so lambda is plus minus 4. So putting the value of lambda equals to 4, we will get x coordinate 9, 2 into 4 plus 1, y coordinate minus 12 minus 1, that is minus 13, z coordinate 4. Putting lambda equals to minus 4, we will get x coordinate. So our option number A is correct. Moving for the next option, lambda equals to minus 4, minus 8 plus 1, that is minus 7, 12 minus 1, that will be 11 for y, and z is minus 4. So the correct options are A and C. Now, moving to the next question. Let's try to understand this question. A plane through the line has the equation. See, this is a plane which is through this line. So, the conditions will be the line will be perpendicular to the plane. So the direction ratios of perpendicular to this plane are 1 1 1. Let's check. 1 minus 2 1, 1 into 1 minus 2 into 1, 1 into 1, this coming out to be 0. So this plane can pass, and the coordinates from which the line passes is 1 minus 1 and 0. Are these coordinates satisfying? Option A, yes, these are also satisfying the equation of plane. So our option number A is correct option. So you do not require to solve everything. Secondly, 3 into 1, 3 into 1 minus 4 minus 1. This is not equals to 0. No need of this option. Then option C, 4 into 1 minus 1, 1 into minus 2 and minus 2. This is coming out to be 0. Let's check it for the point also. 4 minus 1 and this is 0. This is 3 equals to 3. So this is satisfying the point as well as the condition for the direction ratio. So option C is correct. Moving to this one, 3 minus 4 plus 1. This value is coming out to be 0. Now let's check for the point. 3 minus 2 plus 0. Is this value coming out to be 0? No, this is not coming out to be 0. So this is not the correct option. So our correct options are A and C. So if you will do it like this, it will hardly take 1 minute, 2 minutes maximum. Got it? Now moving to the next question. The equation of plane is 2x minus y minus 3z equals to 5. A, B, C and D are the 4 points. Which of the 4 line segments are intersected by the plane? See, what does this mean that the equation, if we are writing the, if we are having this x-axis, this y-axis, if we are having a line, then we say that the equation of this line is ax plus by plus c equals to 0. What does this mean? This means that any point, any coordinate x comma y which is lying on this line will satisfy this condition, that is for that particular value of x and y, for that ordered pair the value of LHS will be equals to RHS, that is the LHS value will be 0. And we know that what lies between 0 is for 0, if this side is negative this will be positive because the point satisfying it is 0. So it might happen the points on this region will give us the negative value, or this region will give a positive value, or it might happen that this region gives us the negative value and this region gives us the positive value. So between this positive and negative value lies are 0. So if same condition what we were doing in the line, if we are having the 2 points on the opposite side, let's say that we are having this values, here it is getting negative values, here getting positive values. If we are having these point A, B, C, so on substituting the coordinates of A, this value will be negative. For substituting the coordinates of C, this will be negative. So when both the signs will be same, we will say that these two lie on the same side. And for A and B, A is giving us the LHS negative and B is giving the LHS positive. That is, they both are lying on the opposite side. Similar thing happens for a plane. If we are going for a plane, then let's say this is x-axis, y-axis, z-axis, and we are having some plane like this. So if a point lies on the other side, then it may have a value positive or negative, and for the other side, it will have a value positive or negative. Let's check out what are our points lying. So for point A, the value is 2 minus 1 minus 3. This value is negative. For point B, our value will be 4 minus 1 plus 9. This value will be positive. No need of calculating. Oh, sorry. 5 is there, na? Minus 5. And this is also minus 5. Rewrite this equation as 2x minus y minus 3z minus 5 equals to 0. So for point C, it will be 2 plus 2 plus 6 minus 5, obviously positive. For point D, this will be minus 6 minus 1 minus 6 minus 5, obviously negative. So we can say that point A and B will lie on the opposite sides. Similarly, to opposite sides, the point will be lying will be A and B. B and C are lying on the same side, but A and C are lying on the opposite side. Similarly, B and D are lying on the opposite side. We can say on the same side we are having the points AD, and on the same side we are having the point BC. Now it has asked which of the following line segments are intersected by the planes. If these 2 points are lying on the same side, they will not intersect the plane. But if the 2 line segments are on the opposite side, they will intersect the plane. So which will intersect? AB. Is our option AB is there? Yeah, B1. AC, it is there. BD is not there. Will AD intersect? No, because it is on the same side. BC will intersect? No, it is on the same side. Clear? So This was our questions on line and plane. Thank you, class.